Hey y'all, today's objective is polynomials, just a little introduction to polynomials. Getting some vocabulary for you. A monomial is either a number, a variable, or the product of numbers and variables together, product only. And examples of monomials could be whole numbers like 4, 3m, 2n squared, or negative 5x. So those are examples of just one term. It's a monomial, and it could be numbers, variables, or product of numbers or variables. After a monomial, we have a binomial. And a binomial is two terms together separated with an addition or subtraction sign. So two terms, for example, this is a binomial, 3x minus 4, or 2 plus 7x squared. Notice there's two terms. That's a monomial. That's a monomial, and then when you put them together with a plus or minus, that's a binomial. Bi meaning two. Trinomial is three terms separated with addition or subtraction signs, and here's an example of a trinomial. X squared plus 2x plus 4. And then if there's more than 1, 2, or 3, if there's 4 or more, we just call it a polynomial. But they all could be called polynomials because a polynomial is the sum of monomials. So we have specific names, kind of like we call triangles, squares, pentagons, hexagons, but if something is, a polygon, it kind of classifies something that might have 14 sides. But they can all be called polygons, and then we have specific names for triangles and quadrilaterals and pentagons. So monomial, binomial, trinomial, those will be the kind of three main ones. Polynomial is all of them. And standard form for a polynomial is when you write with decreasing exponents, meaning from left to right. So you start with whatever terms have the largest exponents, and then they go decreasing down. So from left to right, well, I guess from this way, from left to right. So this one is actually in standard form because this has an exponent of 2, this has an exponent of 1, and this, if it had a variable, would have an exponent of 0, but this doesn't have an exponent. So that one would go last. All right, so we're going to do some examples with polynomials. So example 1. I got distracted by the message on the board. Okay, example 1, write the polynomial in standard form and classify. So let me fix this as standard, and this is u try d. Okay, write the polynomial in standard form. So we need to rearrange the form so the exponents are decreasing as they go from left to right. So in part A, the exponent, the term with the largest exponent is right here. So we would want to put that one first, 5x squared. Then the next largest exponent goes second, which would be just this x because it has an exponent of 1. And it's a positive, so we would say plus x. And then the minus 9 would go last because it doesn't have a variable with an exponent. So now it's in standard form. And this has 3 terms. So if it has 3 terms, it is a trinomial. So that's how you would do these examples. Example B, we take the term with the largest exponent. We want to put that first. Now because it has minus 3x cubed, that means this is a negative term. And then the next term would just be plus 2x, it's positive. And there are only 2 terms, so this is a binomial. Letter C, this is 5n squared. We need the largest exponent. In order to put it in standard form, we need the largest exponent. So I have an exponent of 4, 1, and 2. This has a 1. So I'm going to put 2n to the 4th first, and it's a positive. And then 5n squared is going to go next, minus 7n, because it has an exponent of 1, and then we end with our constant. If it's just a number, we call it a constant. 1, 2, 3, 4. This has 4 terms, and we don't have a special name for that, so we'll just call this a polynomial. A polynomial. All right, u try d, posit u try d. All right, if you want to put d in standard form, you need to put the 3x squared first, and then minus 5 because we want to start with our largest exponents and then go decreasing from left to right. And this is a binomial. This is a binomial because it has two terms. Okay, next, example 2, simplifying polynomials. Simplifying polynomials. This is very much like combining like terms, CLT, combining like terms. And what we're going to do is we're going to add our coefficients, but we have to make sure that they are like terms. They have to have the same variable and the same exponent. So in example A, we need to first find like terms, and I can see that these are like terms because they both have an x squared. And if they're like terms, then we're just going to add the coefficients. 3 and 4 would be 7x squared minus 2x and then minus 3. So I kept the minus with the term, and it's already in standard form, so I'm done. I don't need to do anything else with that one. Let's do B together. In B, I'm going to have to distribute right here. In order to simplify this, I have to distribute. So I'm going to get 4x squared minus 8x. And I'm going to bring everything else down. So I distributed that 4 to the x squared and to the negative 2x. Now I can combine my like terms. I'm simplifying this polynomial. X squared plus 4x squared is 5x squared. And then I want to go ahead and put it in standard form. So I'm going to put my minus 8x next because I want to just put it in standard form, and then plus 2 at the end. So first you have to distribute just like we've done before, and then you are going to combine like terms. Letter C, I need to distribute the 7. So 7a squared minus 14a, and when you distribute, you multiply, plus a squared minus 6. Then I'm going to combine like terms, and so I see my like terms. 7a squared plus 1a squared is 8a squared minus 14a minus 6. And it's already in standard form because my exponents, my variables with exponents, are decreasing from left to right. Okay, the last one is a U try, so pause it and U try, and then press play. Now on this one, you have to distribute it 3 times because you have 3 terms in the parentheses. Negative 2 times 4 is negative 8. Negative 2 times 2y is negative 4y. And negative 2 times 5y squared is negative 10y squared plus 9y squared. Next, I want to combine like terms, and so I see I have like terms right here. Negative 10y plus 9y, so that would be negative y squared. Then I want to go ahead and put it in the standard form, so I'm going to put minus 4y, and then minus 8 would be my last one, and that is in standard form, too. All right, so I hope you got that one right. All right, my last example. All right, example 3, write an expression for the perimeter of this triangle. So perimeter means we add up all the sides, and I have an isosceles triangle, so it has at least 2 pair of congruent sides. When you have these little marks, that means these 2 sides are the same. So if this side is 2x minus 3, that means this side also is 2x minus 3. And if I want the perimeter, I need to add all 3 sides. So I'm going to start with an expression. I'm going to add 2x plus 3 plus 2x plus 3 plus x plus 11. I've just added my 3 sides, which are actually variable expressions instead of numbers, measurements. But I'm going to add all those up, and I'm going to combine like terms. 2x, 2x, and x is 5x. And then 3 and 3 is 6, and 11 is 17. So 5x, oh wait. I messed up. This is 2x minus 3, and this is 2x minus 3. Sorry, 2x minus 3, 2x minus 3. I don't know why I said plus 3. Negative 3 and negative 3, I knew something wasn't right, is negative 6 plus 11. So we have two negative 3's and an 11. So when you combine like terms, that's actually a 5, right? 5x plus 5 would be your perimeter. And we can't go any further because we don't know what x is. If I told you what x is, then you could continue solving it. But the whole point of this lesson was simplifying polynomials and what polynomials are, and we will practice more in class.